Welcome to chemistry classes. In this video we are going to discuss about reactivity of haloarenes. Reactivity of haloarenes, this is part 2. Here we have to discuss nucleophilic substitution reaction. Nucleophilic substitution reaction. There are different chemical reaction over here. First we have to discuss here replacement of hydroxyl group. Hydroxyl mean OH group. Okay, haloarenes mean there is halogen atom. This halogen atom will be replaced by OH group. Okay, this is here replacement of hydroxyl group. Haloarenes reacted with aqueous NaOH with a higher temperature. This halogen will be replaced by OH. Okay, before it was chlorobenzene. Okay, after reacting with aqueous NaOH at a higher temperature, it will change to phenol. Halogen, chlorine replaced by OH, and this compound is called phenol. This is phenol. Okay. And this chemical reaction we know here in an aromatic compound, this is ortho position, meta position, para position. Similarly, this is ortho position, this is meta position. Okay, so here 2 ortho position, 2 meta position, 1 para position. So here nucleophilic substitution of haloarene we discussed here. So if there is any electron withdrawing group in ortho or para position, if there is any electron withdrawing group, here nucleophilic substitution, this type of nucleophilic substitution reaction will be increases. Okay, so here we are talking here nucleophilic substitution reactions of haloarenes. Okay, haloarenes reacted with the aqueous NaOH with a higher temperature. Here temperature around 623 Kelvin and 300 atmospheric pressure. Here two chemical reaction with the aqueous NaOH followed by acidic hydrolysis. H plus represent acidic hydrolysis. Okay, reaction with the aqueous NaOH followed by acidic hydrolysis. Here chlorobenzene will be changed to phenol. Okay, Cl will be replaced with OH minus. We know OH minus, it is nucleophile. This type of nucleophilic substitution reaction, this type of chemical reaction will be increases if there is any electron withdrawing group, NO2, nitro. This is electron withdrawing group. If there is any electron withdrawing group in ortho or para position, this is ortho and para position. Okay, so in this reactant side, if there is any electron withdrawing group in ortho or para position, this type of chemical reaction will be increases. Okay, so here example for this. Okay, here look here. This is ortho meta para. Okay, this is ortho meta para. Here ortho meta para. This is ortho position. So look here, in para position there is here all electron withdrawing group NO2. Here in para position there is NO2. Okay, here ortho and para position there is 2 NO2. Here 2 ortho position there is NO2 and 1 para position there is NO2. If the number of electron withdrawing group increases, reactivity also increases. Here only 1 electron withdrawing group. So for this chemical reaction we have to use 443 Kelvin. Here 2 electron withdrawing group. So here we have to use comparatively less temperature 368 Kelvin. Here 3 electron withdrawing group. So here you just warm the mixture. Okay, so always the product is same. Here chlorine changed to OH. Same like this, product same. But what is the difference? Reaction condition is different. Only one NO2 group 443 Kelvin, here 2 NO2 group 368 Kelvin, 3 NO2 group just warm the mixture. Okay, warm the mixture, it will warm with the water, it will the chemical reaction takes place quickly, and here product phenol, here trinitrophenol is formed. So here we discuss nucleophilic substitution reaction, replacement with hydroxyl group. Okay, here hyaluronines reacted with aqueous NaOH, phenol will be the product. If there is any electron withdrawing group in ortho or para position, reactivity will be increases. Reactivity will be increases with the increasing number of electron withdrawing group. Okay, so here we discuss reactions of hyaluronines. Hydroxyl group replace halogens from hyaluronines, then it will change to phenol. Hyaluronines reacted with aqueous NaOH at a higher temperature and pressure, it produce phenol. This chemical reaction, rate of this chemical reaction increases when there is any substituted electron withdrawing group on ortho or para position. We know this is ortho, meta, para position. If there is any electron withdrawing group such as NO2 group in ortho or para position, rate of reaction, the speed of this reaction will be faster. We can explain this based on this resonance structure. Okay, so this is one hyaluronine. In para position there is one electron withdrawing group. Okay, so here one nucleophile attack this carbon atom, carbon over here, this halogen is attached. Okay, so nucleophile attack over here. So we know here double bond. This double bond mean electron rich center, electron pair. This electron pair will move to this carbon atom. Okay, after that this carbon atom getting a negative charge, and OH and chlorine will be over here. And there will be a series of resonance structures here. Okay, here negative charge. Next, this negative charge will go to this carbon. Okay, and here this is double bond. This double bond mean electron pair. This will go to this carbon. Then we can do like this. Here it will be negative charge, and this double bond will shift backside here, and again it will give another resonance structure. So you can see here during this resonance structure, negative charge will be here in ortho position and para position. Here ortho position, para position, again it is ortho position. So ortho and para position there will be a negative charge. Okay, that's why we are saying here, if there is any electron withdrawing group in ortho or para position, rate of reaction will be increases. Okay, if there is any electron withdrawing group in ortho or para position, this negative charge, the intensity of this negative charge will be decreases by electron withdrawing group, and these resonance structures will be stabilized. They get more stability. Okay, and here that's why if there is any ortho or para position, if there is any electron withdrawing group in ortho or para position, rate of reaction increases. So I will repeat once again. Here we can say here why ortho para substituted electron withdrawing group speed up rate of reaction, and meta substituted electron withdrawing group not increasing speed of reaction. We can explain based on this resonance structure. To explain this, you first draw this resonance structure. Okay, based on resonance structure you can explain this. Look here. Here OH minus is attacking on halogen attached carbon atom. This electron pair will shift to this carbon atom. Okay, then this carbon atom getting a negative charge. Then there will be a 3 resonance structure. Next one, this negative charge will shift to this carbon, and double bond mean we know pair of electron. This electron pair will shift to another carbon, and here next step we can do here double bond, and here it will be negative charge. Again this negative charge will go to this carbon, and here electron pair double bond. Okay, this electron pair go to this carbon. Now this carbon getting a negative charge, and this bond will go back here. Okay, now from this structure you can say here ortho para. Here this two, look here, this is ortho position, this is ortho position, and this is para position. Ortho and para position getting a negative charge. If there is any electron withdrawing group in ortho or para position, the intensity of negative charge will be reducing, because electron withdrawing group, they withdraw electron. Okay, they are withdrawing electron, so intensity of negative charge will be decreases, and they are getting more stability. That's why if there is any electron withdrawing group in ortho or para position, rate of reaction mean reaction between haloarine with OH minus hydroxyl group increases. This type of process not happening in meta-substituted haloarine. If there is any electron withdrawing group in meta position, this is meta position. See here, in meta position there is no negative charge. So negative charges are in ortho and para position. If there is any electron withdrawing group in meta position, they cannot reduce this negative charge. Okay, that's why they are not getting any stability compared to this structure. So if there is any electron withdrawing group in meta position, this type of resonance structures are not happening. Okay, there is resonance structure, but they cannot reduce the intensity of negative charge because they are in meta position. Negative charges are in ortho and para position. Okay, that's why this reaction between haloarine and hydroxyl group increases if there is any electron withdrawing group in ortho and para position. Okay, so here we discussed nucleophilic substitution reaction. Next one we have to discuss here electrophilic substitution reaction. Next one we have to discuss here electrophilic substitution reaction. Okay, reactions of haloarines, reaction 2, electrophilic substitution reaction. See here electrophilic substitution reaction, we know electrophilic substitution of benzene, halogenation, nitration, sulfonation, Friedel-Crafts reaction. These are example for electrophilic substitution. This type of substitution reactions also takes place in haloarines. Okay, in haloarines, halogens deactivate ortho and para position. That's why during electrophilic substitution reaction, electrophilic substitution reactions of haloarine, ortho and para position. Okay, ortho and para substitution takes place in haloarines because halogens present in haloarines, they deactivate ortho and para position. See this resonance structure. This is one haloarine, this is halogen. We know there are electron pair in halogen atom. This electron pair will go to this carbon atom, and here double bond. This electron pair will go to this carbon. That's why what happened here, this double bond will shift to this position, and this position getting a negative charge. Next step, this negative charge will go to this carbon, and this double bond mean electron, this charge electron pair will go to this carbon. Okay, so this double bond will shift to back, and this carbon getting negative charge. Same thing happening here also. So look here, this is ortho position, this is also ortho position, this is para position. So already we discussed this thing. So ortho and para position getting a negative charge. Okay, that's why we know electrophile. Electrophile mean positively charged species. This positively charged species will attack on ortho and para position. What is the reason? Here halogens deactivate ortho and para position. That's why ortho and para substitution takes place. Okay, so here we discuss all this type of electrophilic substitution takes place. First one, we have to discuss here halogenation reaction. Halogenation means we know addition of halogen. This is halogenation. Okay, so already we discussed during electrophilic substitution, ortho and para substitution takes place. So all this chemical reaction, a mixture of product will be formed. Okay, when you add Cl2 to this haloarine, a mixture of product, halogen coming to ortho position, also coming to para position. So one orthochlorobenzene, para-chlorobenzene, this mixture of this product will be formed. But here always the para position will be more stable. Okay, major product will be, a mixture of product will be formed, orthochlorobenzene and para-chlorobenzene formed, but the major product will be para-chlorobenzene. Similarly here nitration, okay, during nitration here ortho-nitrochlorobenzene, okay, or you can say here when you are numbering this one, it is 1-chloro-2-nitrobenzene, or you can say ortho-nitrochlorobenzene, para-nitrochlorobenzene. Okay, so this type of product form. Here also same like this, major product will be para product. Para-nitrochlorobenzene will be major product. Here para-chlorobenzene. Okay, or here you can say this product another way, 1,4 dichlorobenzene, 1,2 dichlorobenzene. Okay, here this is 1, 2, 3, 4. 1-chloro, 4-nitrobenzene. Okay, here this is 1-chloro, 2-nitrobenzene. Okay, so this is the product. So you understand here a mixture of ortho and para product will be formed. Para product always stable product. All electrophilic substitution, para product is not stable, major product. Para product is the major product. Clear? And here also you understand here Cl2. This reaction takes place in presence of anhydrous AlCl3. If there is addition of Br2, anhydrous AlBr3. Okay, and this AlCl3, this is Lewis acid. Friedel-Crafts reaction takes place in presence of Lewis acid. AlCl3, FeCl3 or AlBr3, FeBr3. Clear? This is nitration. This nitration takes place in presence of concentrated H2SO4. Okay. Nitration mean addition of nitric acid. Okay, this reaction takes place in presence of nitrating mixture. Nitrating mixture mean mixture of concentrated nitric acid and sulfuric acid. This is nitrating mixture. This is the condition for this chemical reaction. Clear? Okay, next one we have to discuss here sulfonation. We already discussed halogenation. Also we discussed nitration. Nitration means chlorobenzene reacting with concentrated, a mixture of concentrated sulfuric acid and concentrated nitric acid. It is nitration. Okay, NO2 will be in ortho and para position. There will be NO2. Nitro group will be there. Here this is sulfonation. Sulfonation means here haloarines reacting with concentrated sulfuric acid. Here no concentrated nitric acid, here only concentrated sulfuric acid and heat. So there will be sulfonation. During nitration, NO2 group will be there in ortho and para position. During sulfonation, SO3H will be there. SO3H. In ortho and para position, there will be SO3H. Okay, this is 2-chlorobenzene sulfonic acid. Okay, here benzene ring, on the top of benzene ring there is SO3H. It is called benzene sulfonic acid. Benzene sulfonic acid. Here SO3H and chlorine. So we have to give number 1 for SO3H. This is number 2. This is the order of priority. Okay. So here it is 2-chlorobenzene sulfonic acid. Okay. And here it will be 1, 2, 3, 4. 4-chlorobenzene sulfonic acid. 4-chlorobenzene sulfonic acid and 2-chlorobenzene sulfonic acid, and this is para product, and para product will be there. So during sulfonation, haloarenes reacting with concentrated sulfuric acid and heat, that is sulfonation. Next one we have to discuss here fourth reaction, electrophilic substitution reaction. Last one here, Friedel-Crafts reaction. Friedel-Crafts reaction. Okay, so here Friedel-Crafts reaction, there is alkylation and this is acylation. This is alkylation. Alkyl group will be added. This is acylation. Acyl group will be added over here. So during this chemical reaction also ortho and para position will be substituted. Okay, here CH3Cl. So CH3 will be substitute on ortho and para position. Okay, CH3. And here we know during substitution reaction, here one of this hydrogen will be substitute. This hydrogen and this chlorine combine to form HCl. So there will be HCl side product. Here CH3 will be substitute on ortho and para position. We know para product will be major product. Para product will be major product. Okay. And here this is the order of priority to give number 1 for chlorine here. So here 1 chloro 2-methyl benzene. 1 chloro 2-methyl benzene. Here 1, 2, 3, 4. 4. Okay. So here it will be 1 chloro 4-methyl benzene. 1 chloro 4-methyl benzene. Okay. You have to write like this: 1 chloro 4-methyl benzene. Okay, you have to do here 4, here 1. You have to follow this rule. Okay, so this is alkylation. During acylation, so remember here CH3Cl, so Lewis acid AlCl3, and here CH3COCl, so here also anhydrous AlCl3. Okay. So there will be Lewis acid must be there. This is the condition for this chemical reaction, and this is acylation. This is chlorobenzene. Chlorobenzene reacted with acyl chloride CH3COCl. Here this chlorine, one of this hydrogen, HCl will be side product, and CH3CO will be substitute over here. Okay, look here, CH3CO means CH3 C double bond oxygen Cl. This Cl will be replaced, and here this carbon will bond in ortho or para position. Clear? So here this is ortho product and this is para product. Okay, and here para product will be the major product. Here also para product will be major product. Here when you are giving number 1 priority acyl group, this is acyl group number 1, this is number 2. Okay, so here 2-chloroacetophenone. Okay, this is here benzene ring, on the top of benzene ring C double bond oxygen CH3. This acetophenone, we will say acetophenone. So here 2-chloroacetophenone. 4, this is here 1, 2, 3, 4. 4-chloroacetophenone. Major product will be para product. 4-chloroacetophenone will be major product. Okay. So this is CH3COCl. Remember, CH3COCl means CH3C double bond oxygen Cl. This chlorine will be replaced, and bond here, this bond will go to the ortho or para position, and this reaction also takes place in presence of AlCl3. Okay, so these are the things you have to remember about electrophilic substitution reaction. Okay, next one we have to discuss here reaction with metals. Haloarenes react with metals. We already discussed previous video. Haloalkanes react with metals and form corresponding product. We discussed Woods reaction. Haloalkanes reacted with the sodium in presence of dry ether. It produced hydrocarbon. This is Woods reaction. Similar reaction you can see here. Haloarenes reacting with the metals. Haloarenes reacting with the metals, we have to discuss here two reaction: Woods-Fittig reaction and Fittig reaction. Both are almost similar. Okay, so Woods-Fittig reaction mean here aryl halide reacted with the alkyl halide in presence of sodium. It formed a hydrocarbon and sodium halide. All these chemical reactions are taking place in presence of ether, or you can say dry ether. So Woods-Fittig reaction mean aryl halide reacted with the alkyl halide in presence of sodium. Reacting with the sodium, aryl halide, alkyl halide and sodium, all this reacting together in presence of dry ether, it producing a hydrocarbon. This is hydrocarbon. Okay, here this halogen replaced by R. Okay, and here sodium halide will be the side product. Okay, you can balance like this. Sodium halide will be side product. Okay, and here another one. This is Woods-Fittig reaction, and the next one Fittig reaction. Fittig reaction also similar chemical reaction. This is also reacting in presence of sodium and dry ether, but here no alkyl halide. Here two molecules of aryl halide, two molecules of haloarene. This is aryl halide or haloarene. Okay, the two molecules of aryl halide reacting with the sodium in presence of dry ether, a hydrocarbon will be formed and sodium halide will be side product. This type of chemical reactions are Woods. This is Fittig reaction, two same molecule, Fittig reaction. Okay, one alkyl halide, one alkyl halide and one aryl halide reacting with same condition. This is Woods-Fittig reaction. Okay, so these are the reactions of aryl halide with metals. Okay, here last part of this chapter, we have to discuss here some important compounds. Here some important compounds. These compounds are polyhalo compounds. Polyhalogen compounds mean organic compounds. It contain more than two or more halogen. This type of compounds are called polyhalogen compound. Polyhalogen compounds mean compounds it contain two or more halogen. Such type of compounds are called polyhalogen compound. Here we have to discuss the first compound, dichloromethane. Dichloromethane or called methylene chloride. Dichloromethane or methylene chloride. Important uses of dichloromethane. Dichloromethane used as solvent. It used to remove paint remover. Also it used as propellant for aerosol and manufacturing of dye. Okay, these are the important uses of dichloromethane. Dichloromethane, important uses: it used as solvent, it used to remove paint remover, also it used as propellant for aerosol. Okay, also manufacturing of drugs. Okay, manufacturing of drugs. Okay, so these are the important use. Okay, also we have to remember here dichloromethane, it is harmful. It is harmful for human central nervous system. Okay, it is harmful for human central nervous system. Clear? Next compound we have to discuss here trichloromethane. Next one we have to discuss here trichloromethane. Trichloromethane means CHCl3. CHCl3, trichloromethane. This is also called chloroform. CHCl3, chloroform. CHBr3, bromoform. CHI3, iodoform. So here CHCl3, that is chloroform. Okay, chloroform. This chloroform, the major use of chloroform, this is important solvent for fat, alkaloid and iodine. Chloroform, this is very important solvent for iodine, alkaloid and fat. Okay, here chloroform it used in the production of freon and refrigerant. Freon and refrigerant R22. Okay, we know the liquid which used in refrigerator, this is refrigerant. Okay, so here chloroform used in the production of refrigerant. This refrigerant, it is R22. Okay, and here this chloroform CHCl3, it will oxidize in air, in presence of air and sunlight, it will oxidize. After oxidation, it produces a toxic gas. It is called phosgene, COCl2, phosgene. Okay, so here chloroform in presence of light and oxygen, or you can say light and air, it will oxidize and it produce a toxic gas, it is phosgene. That's why chloroform will store in dark. Okay, dark bottle. Okay, that's why we using dark bottle to prevent oxidation of chloroform. So here chloroform, it is important solvent for fat, alkaloid and iodine, and it used in the production of freon and refrigerant, mainly refrigerant R22. Okay, and chloroform, it will oxidize in presence of sunlight and air and it forms COCl2. This is phosgene. This is poisonous gas. Okay, these are the important point we have to remember about chloroform. Next one we have to check here carbon tetrachloride, CCl4, carbon tetrachloride. Carbon tetrachloride, it also used in the manufacturing of refrigerant. Also it used as a propellant for aerosol. Also it used in the production of CFC, chlorofluorocarbon. Okay, so here carbon tetrachloride used to make refrigerant, aerosol, propellant. Also it used in the production of CFC, chlorofluorocarbon. Okay, also carbon tetrachloride used to make cleaning fluid. Okay, it used as cleaning fluid. Also it used as fire extinguisher, cleaning fluid. Okay, also carbon tetrachloride, it causes liver cancer in human being. Liver cancer. Okay, it causes liver cancer. Also it causes skin cancer. Also it causes eye diseases. Okay, carbon tetrachloride is harmful for human beings and other animals. Okay, so carbon tetrachloride, it causes liver cancer, skin cancer. Also it causes eye diseases. Okay, also here carbon tetrachloride, it causes ozone layer depletion. Okay, so here carbon tetrachloride, it used to make refrigerant, it used as propellant for aerosol, and it used to make chlorofluorocarbon, CFC, chlorofluorocarbon. Also it used as cleaning fluid, fire extinguisher. It is harmful for human being, liver cancer, skin cancer, eye diseases. It also causes ozone layer depletion. Okay, next one we have to understand here freons. Freons mean these are the compounds. These are CFC of methane and ethane are called freons. Chlorofluorocarbons. Okay, freons mean these are chlorofluorocarbon which contain methane or ethane. Methane mean one carbon atom, ethane mean two carbon atom. Okay, chlorofluorocarbon which contain one or two carbon, such type of compounds are called freons. Okay, these freons are non-toxic and these are non-corrosive. Okay, these are non-toxic, non-corrosive and these are easily liquefiable gases. Okay, not toxic, also non-toxic and non-corrosive, easily liquefiable gases. Okay, also freons mean these are chlorofluorocarbon which contain one or two carbon atom. Okay, here last compound, next compound we have to understand here DDT. Okay, DDT, diphenyl trichloroethane, that is DDT. Okay, diphenyl trichloroethane, that is DDT. This DDT, okay, this full name like this, P, diphenyl trichloroethane. This is full name, and here you remember this is first chlorinated organic insecticide. So which one is the first chlorinated organic insecticide? This is DDT. And remember, this is the structure of DDT. Okay, structure of DDT. There is two, if you found the structure, you have to identify the structure of DDT. Okay, here two benzene ring and there are three chlorine atom. Clear? This is the structure of DDT. Clear? So these are the important compounds we have to remember in polyhalogen compound. Clear? So you can review the video once again, and these are the important points we have to discuss in this chapter. Okay, so thank you for watching this channel.